I am Siddhaling Moholkar, and now I am representing my seminar on the topic PAPR analysis of FFT and wavelet based OFDM system using clipping technique. Now, before that, we are discussing about introduction to OFDM. Normally, digital data is transmitted into two types of the form. First one is a single carrier transmission and second one is a multi-carrier transmission. In single carrier transmission, only one carrier frequency is required, where in the multi-carrier transmission system, more than one, that is number of carriers are required. But it should be taken care that for each and every signal, the carrier frequency should be different. In the OFDM, normally multi-carrier transmission is preferred, where a single data stream is transmitted over a number of lower rate subcarrier. Now, OFDM can be used as a modulation or multiplex technique. It depends on the application of user. If it is used as a modulation, then different type of the modulation, that is ASK, FSK, PSK is preferred. But if it is used as a multiplex, then no modulation process is required. Only number of carrier is combined with each other, and at a proper timing we are sending only one data. This figure indicate the multiplex technique. Here input signal is given to the S/P block, that is series to parallel converter. Then this parallel data is added, that is summation is given, it is called as a convolved. After convolution, we will get a single output signal. Now, this is the representation of the different carrier signals. Subcarrier F1, F2, F3 and F4 are considered. It is observed that this signal is represented into time domain as well as frequency domain. But it is considered that the frequency F1, F2, F3 and F4 are different. So, when the data is converted into frequency domain, then it is considered as a power spectral density. Now, we can observe the PDF of each and every carrier signal. If we add these four subcarrier in the time domain, then it will be represented into the figure A. But if it is added into the frequency domain, then it will be located or it will be observed in the figure number 2. And this type of signal is called as a OFDM signal. When we take the PDF of any time domain signal, then it is created as a one main lobe and the side lobes on the either side. So when we add number of carrier signal into frequency domain, then it will be shown into figure B. But it should be taken care that the peak of each and every carrier PDF should be at a different frequency, so that there should be no any frequency interference. It is also called as a inter-carrier interference. But most of the time in the OFDM, the data is transmitted or the data is processed into parallel form. So at a time, one bit of each carrier frequency is available. In that case, it is considered as a one symbol. And if the guard band is not provided in between two symbols, then there may be chances of interference. In that case, it is called as a inter-symbol interference. Now, PAPR, that is peak to average power ratio, it is considered as a main problem of OFDM signal because when we contribute number of carrier signal in the frequency domain, but in the time domain each carrier has a different power level. So when we contribute into frequency domain, then the power is a very important criteria that we should take into consider. So if we are not consider the effect of that peak power, then it will be affect on the property or the operation of that OFDM system. So first one is a high power amplifier, because if we select a carrier signal which has a very high power operation, in that case OFDM system also require a very high power handling capacity, and it will affect on the synchronization at the transmitter and at the receiver side. For the operation of any high power amplifier, always peak power is considered, so that average power is not a sufficient criteria for the selection of power amplifier. So if we are operating on a peak power signal, then we require a large storage capacity of the power amplifier. Then next drawback of the PAPR is it affect on the analog to digital conversion of data or digital to analog conversion of the data, because in the OFDM normally we operate on a digital data, but if the peak power is very more, then there will be change in the value of size of ADC or DAC, because as the power changes, then number of bit which represent the signal will also be changed, and it affect on the size of ADC and DAC. In that case we require a not static, we require a dynamic type of the ADC and DAC. And the another problem of PAPR is it also require a local oscillator with low phase noise level, because as the carrier frequency of each signal is different, we need to compensate that all the carriers. In that case local oscillator plays an important role, but as the uh, we are merging the different signals, then there may be chances of adding the phase noise. So in that case that phase noise should be avoided, and so we require a very phase noise level of the local oscillator. Now normally for the operation of OFDM system, Fourier transform is preferred. When this OFDM system was invented, from that it is used, Fourier transform is used as a basic transform of this system. But in recent years it is observed that wavelet transform is another option for the Fourier. Wavelet has some advantages as compared to Fourier. In the Fourier transform, each signal is represented into frequency domain, but the, the data is not available in the time domain form in the Fourier series or the Fourier transform. So there is a drawback of Fourier transform, that the data is available only into the frequency domain, and this drawback can be overcome by the wavelet. By using the wavelet, the data is available in the frequency domain as well as time domain. Multi-resolution can be obtained using scaling and wavelet function. Therefore, wavelet transform localize in time and frequency both the domain. In addition, it provides a multi-resolution system. Actually, the wavelet has one more property, that it has a symmetry property. This property is very important as the consideration of the complexity of data. Because of that symmetry property, we need to transmit only half of the data at a time, and the another half data is exactly replica of that transmitted data, so that the complexity of the system will also minimize, and this possibility is not available for the Fourier system. Now, these are the some advantages of wavelet. It is localized in both time and frequency. Then basis function is of the wavelet transform are small waves located in different times. Normally, wavelet is considered as a small waves, and the windowing function is used to provide a orthogonality of the OFDM system. Different type of the windowing functions are available. Out of that, we can use any one according to the frequency arrangement of the data, and the bit error rate performance of the system with a wavelet orthogonal is better as compared to Fourier, because as the signal to noise ratio increasing, then bit error rate should be decreased. Means these things are inversely proportional to each other. But practically it is observed that the performance of the BER for the wavelet is much more better as compared to Fourier. Now, in this presentation, I am representing the main technique of the PAPR reduction, and that technique is a clipping technique. This technique is very simple to implement. In this technique, the amplitude of all the signals are reduced to a certain level to optimize the power level, and that threshold level is depend on the transmission capacity of the channel. Means if the channel has a higher bandwidth, then it can follow the higher and higher power. In that case, we need to clip a very less data. But if the channel capacity is less, then we need to clip the more and more data, and it is represented as C of x is equal to x, as that x is less than a, and C of x is equal to a as that x is greater than a, where that a is the threshold level. The drawback of this technique is that loss of data, because as we are clipping the amplitude, then that clipped part is removed from the transmission, so that much data is not available at the receiver. This is a big drawback, as the amplitude difference between two carrier is less, then and only then this technique is suitable. Now, these are the some simulation parameter which are used for the FFT and wavelet based OFDM system. MATLAB, it is a tool which is used for the analyzing the simulation effect. The number of bit per symbol used are the 52, and the number of symbol are passed through the system are 10,000. FFT size is 64, but the wavelet size we can't predict before the operation, because this size is dynamic. It will be changed according to the operation. Number of subcarriers are 48. Signal to noise ratio is from 0 to 30 with a range of 5, and we have observed the BER for 0, 5, 10 up to the 30. Modulation type is preferred as a BPSK. This 64-bit data is rotated through the system, that is from beginning to the end of transmitter, then start of receiver to the recovering of data. This is a one iteration, but in this case we are preferring number of iteration, and that number is equal to the SNR range. Now this is a result of FFT OFDM. The x-axis is a threshold value and y-axis is a PAPR value. The maximum value of PAPR is 1. The conventional and clipping, these are the two results. Conventional is nothing but normal OFDM system, and clipping technique is that blue line indicate the result after clipping the threshold value. As we are increasing the threshold value from 1 to 11, the value of PAPR is going to increase. It is indicate that this clipping is performing a very important role and it provide a very less power value. Operation of this start with a one fixed value of PAPR, but as the threshold value goes on increasing, the difference between PAPR value for the conventional and clipping result is goes on increasing. Now this is a result for wavelet system. In this case, Haar type of wavelet, Simlet type of wavelet, Coiflet and Dobbeches type of the wavelets are used. In the same case also, as we observe the result, as the threshold value is goes on increasing, then the value of PAPR is different for each and every type of the wavelet. But it is observed that Haar wavelet provide a very good result as compared to the other wavelet, and Dobbeches provide a poor performance. The main reason behind this is that the locality or the basis function of the Haar wavelet, it has only two levels. One is a minus and another one is a plus. The amplitude at the minus and plus is the same, means the amplitude from the origin on the either side of y-axis is same for the Haar wavelet, and it will be constant up to the infinity, so that it provide a only single power level, and this is a very important effect of the Haar wavelet. Now come to the conclusion. Now from this we conclude that OFDM using wavelet is also possible, and because of this symmetry property it is less complex than the FFT, as well as more reduction in power as compared to the FFT type of OFDM system. Type of wavelets are available according to the requirement, but most of the time Haar wavelet is preferred. Now these are the some references which is used for this study. Thank you. Thank you. Have a nice day.